Hello Math 1 students, today we are going to do the section 3.1 ready set and go, and for the first part graph each of the functions. So you have to graph it, that's the very first thing, and then later on you have to name 3 points and choose the scale of your graph that will make it possible to graph your 3 chosen points. So what we have to do, I'll show you few methods. Very first question is when you are completely lost and you don't know how to graph it, very first thing is to use a table. So here I have been given a function and we can create a table for that. So I'm just going to create my t table here, and in this case that's your x and this is your f of x that's given negative 2x plus 5. I just plug it in and I will be using it for 0, 1 and 2. I'm taking three values of x, and I'm substituting that. Negative 2 times 0 plus 5, that's going to be 5. Negative 2 times 1 plus 5, and that's going to be 3. Then negative 2 times 2 plus 5 is going to be 1. So we got 3 points here, and I'm going to graph those 3 points. So our first point is 0, 5. Second point is 1, 3. And third point is 2, 1. So I just have to graph it and we are good. So I'm going to draw my axis here. So my axis, that's my y-axis. And now I need to draw my x-axis. This is my x-axis. Alright. So once the axis is drawn, I pardon me, the line is not that straight here, or let me try once more. So let me draw my x-axis. Alright, so this is my x-axis and I'm going to move ahead. This is going to be 1, 2, 3, 4. So I just mark it here, that's 5. Alright, and here it is 1, 2, 3, 4, 5, that's negative 5, that's 5, positive 5, and once I have that, I have to mark my points, and in this case 0 and 5, 0 and 5 is here, then 1 and 3, 1 and 3 is here, 2 and 1, 2 and 1 is here. I got my points, and what I'm doing, I'm going to connect the dots to show my line. That's my line. I grabbed it. So that's the one way of graphing any linear equations or this kind of equation which is in y equal to mx plus b form. Other way is to just simply, like if I go to the second question, that is g of x is what? 4 minus 3x. I can rewrite it as g of x is negative 3x plus 4. That's what? That's similar to y equal to, I can write, that's going to be similar to y equal to mx plus b form. So it means when I compare it, I see m is negative 3 and b is 4. So second way, you just use the slope and y-intercept. You can graph it. First, let's make our axis here. So I just create my x-axis. I will create my y-axis. And now I'll just mark my intervals here. So I would go, this is by 5, this is negative 5, and this is 5. I'll just mark my points now. So if you don't want to create table and you can directly graph it from here, you always start with y-intercept, that's b. So that is here, 4. Once you have the y-intercept, your slope is negative 3, means it's negative 3 over 1, and that is what? Negative 3 rise over run. So means you have to go down by 3 and 1 run. So I'll go down by 3 here, from I keep on going, run 1. That's my point. Go down by 3, run 1. Go down by 3, run 1. Up to you. You can take as many points you want, and I just connect the points. That's my line. Alright, so that's my line. You have another way beside table, but if you want to create table, you can go ahead and create a table and you can graph it. Now next is I see an exponential function. I can, oh, I forgot to write the points here. You can write the points, 3 points. You can pick any 3 points. That was 0, 4, that is 1, 1, and this one is 2, negative 2. I can pick these two, so I just write my answer 0, 4, 1, 1, and 2, negative 2. If I have to do question number 3, I'll just look at the question here. I'm going to use the t-table in this case. So I'll just first make the graph axis, and I'm going to create my t-table, and it's just simply evaluate the function for different values. So that's going to be easier here. That is x, this is hx, that is 5 times 3 to the power x, and h is 0, 1, 2. When I plug in h is 0 in the equation, that gives me 5 times 3 to the power 0. That's what? 5. Then 5 times 1 to the power 0, sorry, 3 to the power 1, that's going to be 15, and then 5 times 3 to the power 2, and that's 45. So we get our points. So here points are basically 0, 5, 115, and then 245, 245. All right, I'm just going to graph it. I need to mark my intervals here. So I could do this. This is going to be 5, this is 10, and it's an exponential. I need up to 45. I need to accommodate 45, so I have to mark it smaller here. So if I start by 5 here, I can mark it 15. Each box is 5 unit worth, and that's 25, 35, 45, and so on. So let's mark our points 0 and 5. 0 and 5 is here. 1 and 15. 1 and 15 is here. 245 is here. Once I graph my points, I need to just connect it. It appears to be an exponential graph like this. It's not a straight line. So this is the way how you graph it. Let's move to the next questions. Next kind of question. I hope you can do 4, 5, and 6 on your own. Next is about, for each graph given, match it to the contextual description that fits best. Then label the independent and dependent axes with the proper variables. Okay, so I'm just going to, so what we will do, we have been given the 2 columns, left side graph and right side it's about the description. So let's read the description and then match it, and just let's label the axis. So very first question, it looks like it says the A description, amount of money in a saving accounts when regular deposits and some withdrawals. So it looks like it's going up, but it's going down also same time sometimes. Some withdrawals, not frequent withdrawals. So when I look at it, I feel like left hand side 10 is the appropriate graph for that, A, and in that case, because it's done over a period of time, so that's going to be days here if I want to, or month, whatever you want to say. And on the y-axis, that's going to be, because it's about money, so it's going to be here. Let's move to the second description, that is talking about B, the temperature of an oven on a day that mom bakes several batches of cookie. So it's about temperature and on a day. So day and temperature, or during that day, like we can talk about time, like 1 o'clock, 2 o'clock. So we have to figure out which one is best describing this situation. So it may be when the mom is baking cookies, so the temperature is going to almost the same when the cookies are baked. So we need to look for which one where it's almost the same. So when I look at the 7, this shows that's almost the same, little bit up and down. So we can talk about that it's time of the day. At different times of the day, the oven temperature was almost the same for baking cookies. So that's our labeling. If I go to the next question, C, the amount of gasoline on hand station before a tanker truck delivers more. So means the amount of gasoline, if it is being like so continuously, so you will see the amount will keep on dropping. So a graph where it's basically telling the story of decrement. So I see it's it's the one where it is decreasing continuously. I feel like it's 11 is matching more for C, where you see it's kind of dropping continuously and it's about days, and what is dropping, it's about gasoline on y-axis. Let's move to D. Watermelons are delivered to a farmer's market every Sunday morning. The number of watermelons available for sale on Thursday. So for Thursday, how many watermelons, like that day, what is going to be the sale behavior for that day, how many watermelons will be available by Thursday. You will see it will be a drop in the number of watermelons, because it will keep on, as you keep on selling them, you will have less watermelons. So question number 9, that looks like that appears to be more, and watermelons are actually the discrete data, so it cannot be continuous one. That's why we're picking this one. That's the difference between 9 and 11. Gasoline is in that case the gasoline is a continuous here. If you measure it, you can measure in decimal, but when you do the um, melons, they're not going to be measured in decimals either, the whole numbers. So here this is the one, time of the day on Thursday, and here it's going to be watermelons. All right, so let's move to the last one. So it's obviously it's going to be 8. E is going to be E here, and let's see how is it. Oh, I forgot to write here watermelon. That's C here. Oh, sorry, that's D, not C, that's D. All right, so 7, and oven temperature, that's B. So E is amount of mileage recorded on the odometer of a delivery truck over a time period, mileage. So it's just like a continuous process. The mileage will keep on going as the time proceeds. So you see it's going up slowly, and that's a E graph, time, and here it is mileage. So let's move to the next questions. I hope you can do 12 and 13 on your own. Let's move to the go part, and for each equation find the value of x that makes it true. And here so it's basically it's about solving it. So let me show you how to solve the first one. 14 10 to the power x is 100,000. All right, so how to do it? So I have to figure out what that x is. So I have to write the right hand expression as base 10, and what power is going to be 1 2 3 4 5 0. So that's power 5. So in bases I can say x equal to 5. That's the answer. All right, because when bases are same, you can compare the it is something like this, because x to the power a is x to the power b. It means you can say a equal to b. Okay, so because of this property of exponents. Let's move to the next one. I'll just go over question number 16, and it's all about solving it. You collect the variables on one side. I would do, basically I add 6x to both sides. I do that, so I get negative 15 is 10x plus 35. And what I would do now, I subtract 35 from both sides. You can start your problem the way you like. Negative 40, that's going to be negative 50 is equal to 10x, and you divide both sides by 10, you get negative 5 is x, or x is negative 5. That's your answer. So I hope you can do the remaining questions in this problem, and please let me know if you have trouble. Thank you so much. Stay safe. Bye.